Well, hi everyone. We got composition of functions, and let's say I have two functions, a function f and a function of g, and what we're talking about when we are making compositions of functions, I have this x, which I'm going to put into the function g, and when I do that, what comes out is another value that is g of x. And then after I figure out that new value g of x, I'm going to put that new value into the function f. And I'll have f of g of x. And that's the combination of functions. So we're putting like one function inside another. And just from here to here, a lot of times you'll see the notation like this, f circle g of x. So I just want to evaluate some things. Let's suppose f of x is equal to x squared plus 2, and g of x is equal to x minus 6. X minus 6. So I want to do the combination function f circle g. I want to find the reverse, see if it's the same, g circle f, and heck, we can even do something like, just for the fun of it, g circle g, kind of put one function inside itself and see what happens there. Now, first one we have is f circle g of x. And I do like this, helps me. That's f of g of x. So g of x is equal to x minus 6. So I'm going to take the g of x out, put x minus 6 in its place. Now, the f of x function says square your input and then add 2. So my input is not just x now, it's x minus 6. I'm going to square that and then add 2. Now, I'm going to simplify this. I need to take x minus 6 times x minus 6. Well, I FOIL that. That's x squared minus 6x minus 6x. And negative 6 times negative 6 is plus 36. So that's x squared minus 12x plus 36. So this is equal to x squared minus 12x plus 36. That's this part. And then we'll add 2 to that. And I have x squared minus 12x plus 38. So I've evaluated that. This is f circle g of x. Now let's see if we can just reverse it. We get the same thing. G circle f of x. Now that's g of f of x. And that's g of f of x. Sorry, got distracted for a second. That's g of, now f of x is x squared plus 2. So I'm going to take x squared plus 2 and put it into the g function where that input is. G of x equals x minus 6. I'm going to take the x out. I'm going to put x squared plus 2 in its place, and then the minus 6. And that's actually equal to x squared minus 4. So g circle f of x, the combination function there, is equal to x squared minus 4. Now notice, so that they're not commutative. We can't just reverse it and say they're equal. Now I said g circle g of x, so I'm going to put the g of x, I'm going to put it inside itself. So I'm going to take g of x is x minus 6. So I'm going to replace g of x with x minus 6. And now when I plug this in back to the g function, my input now is x minus 6. It's not x anymore, it's x minus 6. So it's x minus 6. That's that input. And then I need to subtract 6 from that. So there's my input, minus 6. So x minus 6 is x minus 12. All right, and that's just playing around with a little bit. There is one more I'd like to do. I would like to just say that let's find one more thing here. Let's find f of g of 3. Okay? F of g of 3. Now one way we can do that is find what g of 3 is. G of 3 is equal to 3 minus 6, which is negative 3. Take my input, it's 3 now. And then g of 3 is negative 3, so we would be finding f of negative 3, which is negative 3 squared plus 2, and that's 9 plus 2, which is 11. Okay, now the other way we could do that, f of g of 3. You see where we have this f circle g of x? That's f circle g of x, remember, is x squared minus 12x plus 38. So if we take f circle g of 3, that would be 3 squared minus 12 times 3 plus 38. And then that is 9 minus 36 plus 38. 9 minus 36, that's negative 27, plus 38, which is 11. So just a couple approaches to doing that one. All right, well, that's all I have for you right now. Take care and God bless.